In today's lesson, we'll be looking how to draw polynomials using their factored forms. All right, let's just recap how we draw the graph of a quadratic when it's in this form. So that is, we've got it factorized, x subtract something times x subtract something, and then we have this big multiplier. All right, so here's an example. Y equals x subtract 3 times x plus 4. And of course, the multiplier there is just 1. And here's the graph over here. We know it's a parabola. It's an uppy. This one happens to have 2 x-intercepts. And we know the x-intercepts just by looking at this. Formally, what we're doing is we're actually asking ourselves, when is this equal to 0? And the big idea is we're using the zero factor theorem, which says if something times something equals 0, then that's going to happen when the first thing is 0 or that thing is 0 or both. So that means we can look at this whole expression and it's going to be 0 whenever that is 0 or when x plus 5 is 0. We can see straight away that's going to happen when x is 3. That's going to happen when x is minus 5. All right, just a little warning. You'll see the robot warning down there. Be very careful. It's easy when you see something like this, x minus 3, x plus 5, to go, the intercepts are minus 3 plus 5. They're not. The intercepts are plus 3 minus 5. So you've got to look carefully at these signs. All right, and that's why we like to write it in this form, minus alpha minus beta, because that then makes the roots alpha and beta. Well, you might notice I just used the word there, root. You'll hear me use 2 words, zeros and roots. For the work we're doing, they're interchangeable. So the zeros of the polynomial are where the polynomial is 0. Technically, we use the word root for the equation. When is it equal to 0? But we'll use these words interchangeably. Okay, let's remind ourselves of the effect of the multiplier if we have an a multiplier in front. So the blue curve here is just my standard, just multiplied by 1. Technically, the word is monic. There's the monic version. The green version is multiplied by 2. And notice what's happened. It's still going through the same zeros because it's still 0 at the same place. What's the 2 doing? The 2 is taking this and making it steeper, and it's rising faster up here. Here's a negatized version, and it's turning it into what I call a downy. All right, let's look at this question. This can trick some people. What if the form looks like this? X times x minus something. So here we have y equals x times x minus 3. Hopefully in your mind, you can kind of see it as this, x subtract 0. And so clearly this is when x is 0. Or you can just go straight in, say when x is 0, this is 0. And so what that's created is a root at the 0 value and at the x equals 3. Now that we know how cubic functions look, if I was to give you this expression, y equals x minus 3, x plus 4, x plus 1, we could draw the graph. We know the cubic shape is this, or an uppy, and this part will be 0 when x is 3, this part when x is minus 5, this when x is minus 1. So this bit here makes this root, the plus 5 makes that root, and the minus 3 makes that root. Okay, now I'm imagining some of you are wondering, when I go to draw that curve, how do I know how high to draw? How do I know that turning point? How about this turning point? And the answer is, at this stage, we don't know. So we just do our best. We just naturally just draw a flow. No one's going to criticize you. Now, we do have a clue, however, what this value is, and that's going to help us draw the curve. So what is this value? This is the value when x is 0. What is that value? We can get that pretty quickly by looking at this and imagining x is 0. So it's 0 minus 3, 0 plus 5, 0 plus 1. So it's negative 15. So therefore, that point is 0, negative 15. And that's going to help us draw the curve. Let's look at a quadratic one. If you remember, our quadratic functions generally are in the W shape or the M shape. This one, okay, that's going to give me a 0 at positive 3, at negative 5. That's going to give me 1 at 0, so we're going through the axis. And that's going to give me 1 at negative 1. So we put these points in. We know we have the W shape, and we fit a W shape into that. Again, remember, we're not worried about how far to go down on these. We're going to learn later how to find these points. All right, now it's your turn. So looks a bit scary at first. Here's a function, and I want you to have a try at drawing it. So pause the video, have a try, and then resume. Okay, I hope you had a try. Now let's analyze this. What have we got? How many x factors have we got? Well, we've got 4. So it's a quartic. The negative tells me its general shape is going to be something like that. So let's draw our axis, and we're going to really spread these out. So we're going to have a 4, and so I'm going to go up to a 4. So 1, 2, 3, 4. There's a 4. So there's the first one. We're going to have a 1. We're going to have a -1 and a -2. All right, now, I think I see how my M shape is going to go. Let's try and work out what the y-intercept is. So when we have 0, it's that. X is 0, -4, -1, +1, +2. So it's going to be 8. How many negatives we've got here? We've got 3, so it's going to be negative, so it's going to be -16. So I'm just going to call that -16. All right, so I'm just going to draw a curve. So we're going to go here, here, here. I've got too much wobble in there. Sorry, my stylus isn't very good. Okay, we definitely don't want to wobble like that. All right, so I'm going to start that one again. All right, so I'm going to go up through here, up here, and down. So I'm going to be something like that. All right, it's a bit hard with my stylus, but you should be able to do something a bit neater. Let's mark that as being -16. All right, let's see what the answer is. I've got one ready to go. That's not bad. It's not bad. I haven't quite got the exact shape right and the proportions of the bumps, but at this stage of the game, we're not going to worry about that. We will find them. And yes, I got the intercept correct. All right, I've got one more for you to try. This one here. Again, stop the video, have a try, and then we'll do it together. All right, so it's a cubic because it's got 3 things. The intercepts are going to be 0, -2. Oh, now careful here. This is 3 minus x. So that's going to be 0 when that's 3. Now multiply the x bits, x by minus x. So the leading term is minus x squared. So we got a downy cubic like that. Okay, so I think I know what I'm going to draw now. X, Y. All right, so I'm going through the origin. -2, so why don't I just do that? And 1, 2, 3. Okay, so I want a downy, so I'm going to come through here, up here, and down through there. Again, you'll do a better job with pen and paper. Put arrows on. Let's make it really nice. Let's actually label it. And there's our function done. Here's the one I prepared earlier. Pretty good. Pretty good. Okay, in the next video, we'll look at slightly harder polynomials featuring multiple roots.